Hey guys, hope you guys are doing well. Haven't posted a video or anything for a while, so I've heard from most of you guys. There's a couple of you I haven't heard from a whole lot, so please don't be afraid to email me. I know some people emailed me quite a few times and then they always apologize for it. You guys do not need to apologize or feel bad for emailing me. If you guys need help, have questions, need clarification, you guys can contact me anytime for any reason. So today we're going to talk about atoms. You guys have already talked about, well, you haven't talked about it, but you did your projects on the atomic history. So you guys have those 14 scientists. You know probably at least a pretty solid idea now of who discovered what, kind of the progression of the discovery of the atom, and how those discoveries all built on each other and how new things were found. So what we're going to talk about today is just some basic stuff. You might remember some of it from physical science. I'm not sure what all they covered, but either way, it's probably been a few years. So with parts of the atom, we have our general electron cloud model. More is what we use now, and not so much like the rings, but you'd have a cloud of electrons out here. So your nucleus is made up of protons and neutrons. We know that protons are positive. Protons are going to be what identifies your atom. So if something has 6 protons, we know it's a carbon. It has 8 protons, we know it's an oxygen. So the proton is going to be what identifies what the atom is. So if the proton changes, you are changing the atom. Neutrons are also in the nucleus. They are neutral. They don't have a charge. So they basically are there to serve as like mass. So they're going to balance out the mass of the nucleus, kind of stabilize the nucleus in there. You can change the number of neutrons, and we'll talk about that in a little while. Electrons are going to be flying around the outside of this, kind of in a big cloud. They do have certain pathways that they follow called orbitals. We will talk about those in a couple of days. But electrons are very, very, very tiny, and they make up almost no mass. They have almost zero mass. They are negative in charge. And these are probably the most important pieces for chemistry because the electrons are what allows different atoms to bond. So with this, just reading your periodic tables, one good periodic table resource for you guys would be ptable.com, just the letter P, the word table.com. It has a ton of information, and you can click on different different elements, and it gives you just like endless information. Whatever you could possibly need is on there. Obviously, a lot of other resources out there too, so that is totally up to you. So with your atomic number, like when you're reading your periodic table, you're going to have the symbol in the middle. So the 2 letters, the first letter needs to be capitalized always. Underneath that will be the element name. At the top is going to be your atomic number. So the atomic number is going to be the number of protons that are found in there. So as long as you have a neutral atom, protons and electrons will be equal, and then we will have to do some simple math to figure out the neutrons. So protons and neutrons are going to be equal to your atomic number. For your atomic mass, that's going to be at the bottom here. So you can use this to find your neutrons. So if you're going to find neutrons, you're going to have your atomic number subtracted from your atomic mass. So we would round this because we know that there can't be fractions of neutrons. So you would round this to the nearest whole number. So 20 minus 10 would give us 10, obviously. So for neon, you would end up having 10 protons, 10 electrons, and then 10 neutrons once you subtract that. If you do another example here, we have carbon. So carbon's atomic mass rounded to a whole number is 12. Its atomic number is 6. So we know right away the atomic number tells us it has 6 protons. We're talking about a neutral atom. It's also going to have 6 electrons because the negative and positive balance. And then the number of neutrons is going to be your atomic mass minus your atomic number, which in this case is also 6. So when you guys are writing atomic symbols, this will be important because you're not always going to have the same mass number that you would find on the periodic table, depending on if it's an isotope or not. And you can also put in the charge on an atomic symbol. So This is basically a shorthand way of writing some information here. You always want to put the symbol in first. So, if it's a C, you put the C there. Then you want to put your atomic number down low, like where the Z is here. So it's going to be a subscript in front of the symbol. So on the left-hand side on the bottom is where the atomic number goes. And then on the left-hand side on the top is where the atomic mass goes. So this is the mass for that particular element in that situation. So this could vary a little bit. Basically, it's just flipped upside down from the periodic table. So that kind of brings us to some other ways that we can, the reason why we have the symbol notation is that we have ions sometimes in isotopes. So ions is going to be whether your atom is positive or negative, basically. So an ion is going to form when your atom loses electrons or if it gains electrons. Okay, so let's see here. Oopsie, here we go. So what's the charge on an electron? We know that electrons are negative all by themselves. So if you have more electrons than protons in your atom, so there's more electrons than protons, the overall charge will be negative. And then the opposite is also true. So if you have more protons than electrons, since the protons are positive, you'll have an overall positive charge. So that brings us to our cations. Okay, so cations are going to be just the name you use for a positive ion. One way to remember it is this, kind of silly, but cations are positive. Okay, so kitty cat. I know one student in particular that will enjoy that cat joke. You're welcome. So these are going to be formed by the atom losing electrons. Okay, so if you lose electrons, it turns into a cation because it is positive. Okay, so this happens a lot in particular with metals. So we have metals can form cations. So if we have calcium and it loses 2 electrons, it's going to become positive by 2 electrons. And that's how you would show this. So back where we were talking about writing the symbols, you could write the mass up here, or like at the top on the left, and then you could write the atomic number on the bottom on the left, and then the charge, now that it's an ion, goes on the top right. So how many electrons did calcium start with? It started with 20 because you can find that on the periodic table. Its atomic number is 20. How many did it end with? Because we're adding 2 positives, it's going to end with 18. Sorry about that, I got interrupted there. So you're losing 2 electrons here, and this keeps popping up, I'm so sorry. But you're losing 2 electrons, so if you started with 20, you'll end up with 18, which gives you a positive 2 charge. Anions are the other end of that, okay? So anions, they're angry. That's one way to remember it. So an anion is a negative ion, okay? So they're negative. That's one way to remember it, like A-N-I-O-N. So anions are negative ions. That's going to be formed when atoms gain electrons, okay? Oh, there we go. So these are mostly going to be nonmetals from your right side of your periodic table are going to form anions. So they're going to be gaining the electrons during bonding. So if you have oxygen, oxygen has 8 electrons to begin with. So if we add 2 electrons to that, we're going to end up with a charge of -2 because now it has more electrons than it had protons. So how many did it start with? It started 8 because we found that on the periodic table. How many did it end with? Now it has 10. So overall, like your key point from this is that if an atom has more protons than electrons, it's going to be a cation and have a positive charge. Okay, so this would be if it loses electrons, it becomes positive, which is called a cation. If an atom has more electrons than protons, it will be an anion and have a negative charge. So if an atom is gaining electrons, it's accepting electrons in whatever bond it's forming, it's going to take on those negative electrons and have a negative charge. So along with that, so when we're writing our ions in our atomic symbol, there's always a way to show what you have. So if you have a reaction, you end up having an ion, you have to denote that somewhere, okay? So we talked about the symbol already. So you have the chemical symbols. This is aluminum, so capital A, lowercase l. On the top left, we're going to have the atomic mass, and then the bottom left, we're going to have the atomic number. Now we're adding on, we have this charge. So this one's given to you, okay? So you have a charge of +3. So how many protons, electrons, and neutrons does that mean you have? So protons, we know the protons is the same as the atomic number. Neutrons is going to be the mass minus the atomic number, so that gives us 14. And then the electrons, in this case, you have a +3 charge, which means you lost 3 electrons, which gave it its positiveness. So you lost 3 electrons. We know that normally protons and electrons will be equal to each other in a neutral atom. This obviously is not a neutral atom because it has a charge. So if you started with 13 electrons and you lost 3 of them, now you have 10. So another way that we can change our atoms is with isotopes. So ions, we'll talk about that more with bonding when we start talking about bonding atoms, but isotopes can create unstable atoms, and that's when you get into radioactivity. So we'll talk a little bit about like half-life and radioactivity, not right now, but probably this unit. So isotopes are going to be atoms that are the same element, but they have different masses. Okay, so they have different masses because they have different amount of neutrons, which we talked about that before. That neutrons only thing they really contribute to an atom is mass. So it's helping stabilize the nucleus. So if you're changing the number of neutrons, you can come up with an unstable nucleus, which can give you radioactive elements here. Whoopsie. Oops. Oh my goodness. Okay, so this one I need to edit. Sorry about that. So I'm not coming on the screen here. So how do you rate isotopes? There's different types of isotope notation. So you can have, so this first one here is the name of the element dash the new atomic mass. Okay, so if you looked up carbon, its atomic mass would be 12. That's the average atomic mass for carbon is 12. But in this case, this is representing an isotope of carbon, so carbon 14. So if you see like carbon 14, carbon 13, that's just an isotope of that atom. So here I need to move these over, but we know that this 14, since it's the mass, should be right here. It should be at the top left corner. So with your symbols, same way you'd write your ions, the mass would be at the top left corner. You can also write it like this, and these I need to pull over here. This is a mess, guys, sorry. So again, the mass would go at the top and the atomic number would go at the bottom. So hopefully you can see that pattern there. So there's 3 different ways to say it. So you can either write out the word dash the mass, you can write the symbol with just the mass in the top left corner, or you can write the symbol with the mass and the atomic number. Okay, so all 3 of these notations are telling us that carbon, this isotope of carbon, has an atomic mass of 14. So if it had 12 as its atomic mass and now it's 14, that means it gained 2 neutrons. Okay, so we're going to look at these. So how many protons and neutrons would you find in these? So oxygen, in this isotope of oxygen, we have an atomic mass of 16 and an atomic number of 8. Okay, so that would mean protons are 8 because that's the atomic number. Neutrons are going to be the mass minus the atomic number. So you'd say you have 8 neutrons. Okay, so if you look on the periodic table, your average atomic mass for oxygen is 16 anyway, or like 15.9 repeating. So this would be just a balance of regular atom. It would not necessarily be any special isotope. So with this one, we have nitrogen. Its atomic number is 7, so that's how many protons it has. Neutrons is going to be the mass minus the atomic number, so we're going to say that it has 8. And then this one's another isotope, so hydrogen 3. So this, again, just another way to write this out. So hydrogen 3 is telling you that this is the mass number. So for protons, you would need to look at the periodic table to find the atomic number. So protons for that would be 1 because hydrogen is number 1. Neutrons is going to be your mass minus the number of protons. So here you have mass is 3 minus protons we found on the periodic table is 1. So number of neutrons for this isotope is going to be 2. Okay, so with your ions and your isotopes, whoopsie, there we go. Both ions and isotopes can be shown on the same symbol. So if you have something that is an isotope, but it's also an ion, you can write that all in one place. So for this, you'd have the symbol, the letter symbol here. Your atomic mass goes in the top left corner, your atomic number goes in the bottom left corner, and then your ion charge goes in the top right corner. So you can use this information to get in, to read and calculate some other information that you can use. So protons we know are going to be equal to the atomic number, which was 16. Neutrons always is going to be the mass minus the atomic number. So in this case, neutrons are 18. And then the electrons, we're going to have the protons plus 2 because the charge is minus 2. Okay, so basically you're adding or subtracting opposite of what the charge is for electrons. So if the charge is -2, it means you have added 2 electrons because electrons are negative. So you're taking on that negative charge. So if you had 16, you add 2, you're going to end up with 18 electrons. Okay, so if we have just some more examples. So if you, whoopsie, I should have timed these differently, I guess. So if you had an ion with 17 protons, 18 electrons, and 20 neutrons. 17 protons tells you what atom you're talking about. Okay, so 17 is the atomic number. Get on your periodic table, find number 17, tells you it's chlorine. Okay, so that 17 comes down here in the bottom left corner. Above that is going to be the mass. Okay, so we know that to find neutrons, you're going to have neutrons. I'm getting myself mixed up here, sorry. So to find your neutrons, you're going to have the mass minus the protons, right? So you'd have your 37 minus the 17, but we're writing this, so you wouldn't know that it's 37 yet. So if we know that we have 17 protons and 20 neutrons, these are the only 2 subatomic particles that have mass, you're adding them together. Okay, so to find the mass, given the protons and neutrons, you add those up to get the 37. The charge on this, you're going to have to find the difference between protons and electrons. Okay, so we know that if there's more electrons, it's going to be an anion, it's negative. So how many more electrons are there here? There's 1 more. So there's 17 protons, there's 1 more electron, which gives an overall -1 charge. Okay, so with ones, we don't have to write ones. Ones are assumed, so you would just need a negative sign there. Same thing down here. So if we had 92 protons, 88 electrons, 146 neutrons. So protons tells us what it is. We look on the periodic table, that's uranium. So we write number 92 down here. The mass is the protons plus the neutrons, so that's what comes up here. And then over on the ion side, we know that there's a difference in electrons and protons. So the difference here is 4. There's 4 less electrons, which means you're going to have an overall positive charge of 4. So this would be a cation. Okay, so just some key points. Your mass number is always going to be on top, your atomic number is on bottom, and the charge goes on the upper right side. We will talk about average atomic mass next time. So now you guys can find your assignment. It is on Canvas, obviously, and it's just practicing these things. Please let me know if you have any questions. I tried to cut it down a little bit. It was like 3 full worksheets, so I tried to chop it up so it wasn't quite so much to work on. And then also I want you guys to do the GIM kit, please, so you can practice some of that atomic history stuff. So please let me know if you have any questions, and I will talk to you guys next time.